And so we're joined tonight by Dr. Danny Faulkner from Answers in Genesis in the USA. And if you've been watching for the last, I don't know how many weeks we've been in lockdown now, but for the last several months, Danny's joined us a number of times, talked about scripture, talked about astronomy. So we've had some really fun episodes, informative episodes with Danny on astronomy. We're going to take a different focus tonight, and we're going to cover three great scientists, Newton, Maxwell, and Lord Kelvin, because we're going to talk about the fact that these men were great scientists, not only great scientists, but they were great men of God, because there's some confusion in the culture today that Christianity and science has nothing to do with each other, where that couldn't be farther from the truth, because we know historically that modern science arose just after the time of the Protestant Reformation in the 16th century. And there was a reason for that. So tonight we're going to take a look at these three men and some of the theories they came up with because of their beliefs. So Danny, it's good to have you with us again.
Thanks for having me.
So should we address the issue first of all about the Reformation and its relationship to modern science? Because all of these men, well, Newton came around the time of after the Reformation, but certainly Maxwell and Kelvin came quite a few hundred years afterwards. But it was important for the Reformation to give the ground for modern science.
Yeah, the Reformation played a key role, though many people don't appreciate it. I believe the agnostic Whitehead actually a century or more ago addressed this issue, and he gave due respect and credit to the Protestant Reformation for largely being responsible for science as we know it. Science just sort of, as we know it, blew up in the 17th century. Around 1600, things began to happen, and certainly a revolution took place, which Newton played a key role in. And many of the major players were English, German, they were in Northern Europe. There have been a few elsewhere in Catholic Europe. Galileo was one, Copernicus was another. They were a bit earlier, some of them. But once the Protestant Reformation took place, science really began to take off, and in Protestant Europe particularly. And the argument is this: the ancient Greeks had a concept of a separation between the heavenly realm and the earthly realm. Things above us were perfect, things below us were not. Now, they meant this in a physical sense. In the heavens, there was perpetual motion. The sun, the moon, the stars, and the planets, they all continually moved. They just kept moving and kept moving. On the earth, you started something moving, it stopped. And you had to keep pushing on something to make it move. And so Aristotle, the 400 years ago, addressed this and said that the natural state of things on the earth, at least, was rest. Object and at rest remain at rest, and objects in motion come to rest unless acted upon by some force. But in heavenly realm, it was different, and they saw things just going on and on and on. So they said, well, motion is a natural thing, and the heavens were perfect, and so the motions had to be circular motion and uniform circular motion at that. And that was a bit of a constraint, but Ptolemy, nearly 2,000 years ago, was able to make a model work, explain using those kind of requirements. And science kind of sat there for 15 centuries or so without much advance to speak of, this minor little pushes forward. Now, this then was picked up by the Roman Catholic Church as they began to embrace Aristotelian thought, particularly through the influence of Thomas Aquinas. They Christianized, as it were, those beliefs of the Greeks, and they kind of spiritualized them as well. The Greeks did as well. The difference was also, spiritually and moral. Things were perfect in the heavens, the heavenly realm where God was, the angels were. Things were not very perfect here. It's a bit consistent with wrought the way they chose to do it, because the Roman Catholic Church eventually developed this belief that only heavenly things were really worthy and dignified. And so the work of the priest and the work of the king were doing the Lord's work. But if you were a farmer, well, which most people were, by the way, you were digging around in the dirt, basically. And that is just the epitome of this fallen world. So if your lot in life is to be a farmer, that's too bad. You're just basically doing a wood, hay, and stubble sort of work. But the priest and king, they're doing the Lord's work. Well, the Protestant Reformation comes along and it changes this entirely. It says, look, all work is worthy of respect and honor if it's honestly done. And it tore down the separation between the secular and the sacred. If you were a plowman called by God to be a farmer, then do so for the glory of God, because he would be honored, and you would be doing the Lord's work yourself if you could be the best farmer possible. And this gave rise to what's called the Protestant work ethic. I heard that growing up, and I didn't know what it was, and it wasn't until years after becoming an adult I finally found out what this meant. And it didn't mean that Catholics were non-Protestants were lazy or slackers or something. It simply meant that from the Protestant Reformation, the Protestant people were more motivated to work, because they were not doing it just to feed their family and themselves, but also to glorify and honor God. And this resulted in a tremendous productivity, both in farming and manufacturing, why the Industrial Revolution took place where it was. It has these roots back to the Protestant Reformation. And also at the same time, it said, look, the world, the nature around us, while it's tainted by this man's sin, it also is worthy and dignified as well. And this made studying the natural world, what we now call science, back then they called natural philosophy, this also became a holy calling as well. If God called you to study this, then study it to the best of your ability, because you can bring honor and glory to God by studying things about his creation. And it made a kind of a worldview there. We know that since God is a God of order and a God of decrees, he declares certain things to be true and certain things operate a certain way. There's order in this. God doesn't change. So, one day he wants this and the next day he wants something else. No, he's pretty consistent in his expectations of us. And so maybe, just maybe, God had imposed that sort of order onto the world. That was a working hypothesis. In ancient ways of thinking about things, the world was chaotic. One day you would do an experiment, the next day you might get a totally different result, and the day after that a different result again. And the Protestant worldview said, wait a minute, God is a God of order. I think since God created the world, maybe there's some pattern here. There's some patterns of things are going to repeat and be, the world's going to be knowable just as God is knowable. And they use that as a working hypothesis. And it turned out to be a very strong hypothesis, because people did find order in all that chaos. They found a consistent set of patterns there. And eventually, some of these patterns came to be called laws, physical laws. People are kind of squeamish about calling anything today a physical law, but it comes from the idea that God has given man law, a moral law, but he's also imposed order onto the universe. And so certain rules that the world obeys, God ordained, they amount to laws that God put there. And so that's the reason why the Protestant Reformation allowed the foundation of science as we know it. Again, it's not just me saying this. It's not people at Answers in Genesis saying this. This argument was made over 100 years ago. And as I said, the agnostic Whitehead made the exact same argument. I'm borrowing from him, and he wasn't even a Christian, declared to be a Christian at all. So it's I think it's a part of the legacy that many we Protestants really ought to know about and ought to be talking about more.
Yeah, a lot of atheist historians today, I think, would recognize the fact that Christianity gave rise to modern science. People like Rodney Stark and others who are famous in that area would certainly say that Christianity was behind the rise of modern science. But we'll talk about the first man, Isaac Newton, because I think he's often used by sort of both sort of secularists and Christians try to claim him for himself, because he's not an easy man sometimes to understand. But I've got a slide here. Let me see if I can put this up, and maybe you could just start talking to us, Danny, about Sir Isaac Newton.
Okay, as you can see there, he lived a ripe old age up into his 80s. He was well, to say he was brilliant is an understatement. He truly gifted. I think of the 1,000 years, he may have been the brightest man who ever lived. A century before that, there was another bright man by the name of Erasmus. He's also in the same league with Newton. Maybe once 100 years, someone that comes along, perhaps. But Newton is one of the most brilliant scientists that ever lived, and he was primarily known for his mathematics and for his physics, but also his astronomy. We're going through a lot of lockdown around the world. You already alluded to this afternoon or this evening. Well, Newton did a lot of his best work when he was like 22 years old. They had a real threat. It was bubonic plague, and there's memories in Europe of wiping out a third or a half of the population more than once. So people were terrified, much more so than you would be from the COVID-19 virus. But he secluded himself because he could, and during that time he devoted himself to study. He was looking at one of the big questions he had was what compelled the moon to go around the Earth every month, as an age-old problem, and he came up with a solution that nobody had come up with. And at the same time, he had unified things on Earth and things in heaven, the kind of unity I mentioned before. A very big step here. In order to do this, he had to devise his 3 laws of motion. He devised his law of universal gravity, and he also worked out calculus. He had to invent calculus along the way. Now you give the publication date there of this Principia, which is the write-up of all that he did, is 1687. But in reality, he sat on it for 20 years. He had actually developed in the mid-1660s during that plague time when he was 22 years old. Now think about that. He invented calculus. Simon, have you ever studied calculus?
Not as in depth as Isaac Newton.
Well, I was a math major in college, in university, and I studied. I had 4 semesters of calculus, and then we used it in physics. The reason why we had to understand calculus was because it allows you to do physics properly. And to me, calculus is kind of the gateway. Once you get through calculus, it opens up all sorts of doors of endless possibilities, applications that calculus has. It's a tremendous thing, but it was necessary to invent calculus to do this. And as I went through the derivations and such of calculus and came to understand it more and more, I look at things that are done in calculus, and I thought to myself, if I lived to be 300 years old, it would have never occurred to me to do this. But it had to occur to somebody, and Newton was it. I might add that Leibniz on the continent also was developing calculus at about the same time Newton was. We do follow Newton's nomenclature more than we do Leibniz, but the time was right. Somebody was going to come up with it, but Newton was the one that primarily, but not solely, gets the credit for it. But he did this when he was 22. The insight that he had was truly remarkable, and it was actually it set out for 20 years. The man was a quirky person. He never married. I think many people looking at it today think that he's on the spectrum, maybe he had Asperger's or something else, but he was not quote unquote normal. He was on the spectrum of the things Asperger's and other things are upon. He probably had some sort of issue like that, which allowed him to focus better than the average person could. And he had some very loyal friends, and he had some people who did not like him at all. Robert Hooke was in that latter category. They were bitter rivals for years. And on the other hand, Sir Edmund Halley was a very good friend, and he was the one who paid for out of his own pocket to have Newton's Principia published. He realized that Newton's work was truly remarkable. He appreciated it far more than Newton did. If it hadn't been for Halley's paying for the publication, we probably wouldn't have any idea who Newton was. Halley played a very important role in promoting Newton. So it was indeed a good friend that Newton had in Halley. By the way, what Halley's big contribution besides that was enough, but he took Newton's laws, which Newton had already applied to the motion of the moon and the planets around the sun, and he applied them to orbits of comets. And he saw a comet in his own lifetime that he checked records of the past and realized it was a comet that had been seen about 75 years prior to that. So he predicted that this comet would come back in the mid-1750s, I believe. And it did. He was long dead, of course, but now we call it Halley's Comet for that reason. So another brilliant man, both English, by the way. when people were talking about the day are from the British Isles, but in the 1600s, England had an incredible collection of people. I already mentioned Robert Hooke. Also, we had Sir Christopher Wren. There were others as well. The society there, the Royal Society, came along at that point, and it was a veritable who's who in the history of science. So the English should be proud of their heritage there. It's
We are.
they made a huge contribution to the development of science at that time.
And I guess some of the controversy surrounding Newton is one of the reasons I think secular people try and claim him for their own is the fact that he puts a lot of emphasis on reason. Did he believe in God, and did that have any effect on how he did his science?
Oh yes, he was a very devout man. He put a lot of effort early on into math and science, but then he walked away from it. He had some bruising encounters with Hooke and others. He didn't take it well, and he finally kind of withdrew, and he spent much of the next 50 years studying theology. The man was adept in scripture. He could read Latin and Greek, and I believe Hebrew as well. He was a very well-educated man, well-rounded man, and he wrote extensively on theology and biblical studies. He wrote about 10 times as much on that than he did upon math and science. His big work was Principia, but in the early 1707, I think, he wrote Optics, which is his discussion of the theory of light. So that's added to his math and physics. But on top of that, the theology outstripped it by a factor of 10. Never published. The man, well, until recently, but he was fascinated with biblical chronology, and he was fascinated with the book of Daniel. He knew the book of Daniel extremely well, and he was made some pronouncements about end time prophecies. He made one decision, one computation, very famously so, that the Lord's return would not be before, I think, the year 2050 or 2070, sometime in the mid 21st century.
It was 1948. He said he would come back.
No, I thought it was 20. It's future date. Maybe he said more than one date, but the date I've always heard is several decades away yet.
Okay, I was reading Rodney Stark this afternoon, and Stark had him down as 1948.
Of course, that's interesting with people would say the modern state of Israel. By dates I've heard have been like 2050. I forget the exact date I've heard from people, but at any rate, he believed that the book of Daniel was truly prophetic. Today many people skeptics look at this, particularly so-called Bible scholars, and they see that how spot on the prophecies are with those different kingdoms over time. And so many Bible scholars supposedly claim that Daniel was written centuries after the fact and just records history in form of prophecy. Newton would have nothing of it. He believed the proper view that Daniel was indeed prophetic, and that to him gave the ring of truth. This thing was truly inspired. So he liked the part there where Gabriel ties it up and says there are a lot of things here that are not yet to be revealed, and Newton felt he was the one to reveal it. So he was fascinated with biblical chronology, biblical prophecy, and scriptures in general. So the man was very devout. He had some peculiar theological beliefs, but he was a student of scripture, and more importantly, he was heavily influenced by Christianity. There's no two ways about it. The man truly was coming with a Christian worldview of some sort.
Yeah, and he didn't separate his science from his theological beliefs. I think as some people would try and assert that he may have been religious, but he didn't impose that on his science. And I think we can see this from a quote in the Principia here, Danny.
Go ahead and read that if you would.
Yeah, it says, though these bodies may indeed continue in their orbits by the mere laws of gravity, yet they could by no means have at first derived the regular position of the orbits themselves from those laws. Thus, this most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being.
Yep, in his Shloim, General Shloim at the end of the Principia, he has a couple other remarks like that. A number of years ago, I heard these quotes And I thought, well, this is too good to be true. Sometimes you hear a quote from somebody and it's just too good to be true. So you need to check it out. So I checked it out and I found out, no, it is true. It's not too good to be true. It's good, but it's also true. He very much invoked God into this. Now, one of the things they say is Newton believed that there was some instability built into the creation. He was impressed with the stability you had with the orbits of the planets, but he thought that over time, slight pulls and tugs, we call these perturbations of the other planets, would cause chaos to rule. It would cause the orbits to slowly change, get worse and worse. And so he believed apparently that God from time to time was compelled to intervene and set things aright once again. So there was a clockmaker of the universe, but also that clockmaker had to come in and kind of rewind the clock a few times occasionally. Now, in all fairness, about the time he died, some other people building on this work were able to develop techniques Newton was able not to develop or overlooked it somehow, and showed that the instabilities that came up were very modest. And actually there's long-term stability. And they said, see, we don't need Newton's God to intervene anymore. But I think that misses the point. I don't think Newton was driven to this a conclusion based upon his theology. I think instead his conclusion was consistent with his theology. The conclusion may have been wrong, but it doesn't mean his theology or his assumptions were wrong in this. It just means the detail of this was wrong. So that's getting into the 1700s, and there was a disaster that happened in the 1700s of what I call the so-called Enlightenment. I think it's one of the worst things that ever happened to mankind. You had about almost a century there where science was a very godly pursuit and very much identified with the God of the Bible. But you had some secularist people, some agnostics and atheists begin to rise. The Enlightenment made that kind of belief possible. It made it respectable. You had people starting out in France, but elsewhere, who began to espouse atheism, which had never been an issue, as near as I can tell, historically in Europe. If people were atheists, they didn't talk about it, at least. And they sort of hijacked science. They said, look, we've got all this reason now. We've got rationality. We have this is man. And so suddenly man is unfettered from the strictures of Christianity. This gets back to the argument of what they call the Dark Ages, that during the Middle Ages, everything was ruled by Christianity, and it held back progress. That was what's called the conflict thesis, eventually developed in the 1800s about this. And so they said, look what can happen once our minds are freed of these strictures of Christianity and the Bible. Well, that's nonsense, because obviously Newton was much a student of the word. He was a product of Christianity. And if Newton did this, he within the confines of a Christian worldview, that puts the lie to this argument that suddenly man's reasoning is taken over. But that's the argument put forth, and they won that argument, even though it was a false argument from start to finish. And this sort of thing is taught in the schools today. It's assumed by everybody, it seems like, that everything was held back until man was freed finally, and they don't realize that it was this, again, the Protestant Reformation that helped free people from this, but they hijacked it, and that's when science began to become a secular enterprise. And by the time you get into the mid part of the 1800s, there are people now arguing that God should not be invoked, shouldn't be considered. And of course, today the people are very vehement about that. It's a major argument people make now.
Yeah, and so we can obviously Newton then was a great scientist, but was a great man of God who very much had an influence over science. But we can maybe turn now to the next man on the list, who's not English. He has roots from your land, Danny.
Yes, James Clerk Maxwell, my land. He's actually Scottish, still British though. I mean, the Brits all claim the Scots as well, and I'm very proud of my Scot heritage by way of Ulster. But James Clerk Maxwell, I would put on the same level with Newton. As you can see there, he lived a couple hundred years later, and he did 150 years later. He didn't live nearly as long as Newton did, unfortunately. And I think had Maxwell lived on, he would his name would even be more popular because he would have figured out some things that other people were not able to figure out. And he was a theoretical physicist, early breed at that point. And here's what's interesting about Maxwell. He was building on the works of others. Throughout time, people knew about magnetic effects. They found things called lodestone that somehow attracted certain types of metals, ferromagnetic things, iron and nickel and things like this. And they also knew of electrical effects, static electricity, and of course, lightning. There were some experiments being done 1770s or so, 1780s, dealing with experiments with lightning. And here on this side of the Atlantic, our Benjamin Franklin, is recognized with that. He did not start those experiments, but he did his own after hearing some Europeans were dealing with it. And then by the early 1800s, a series of experiments were done, which were fascinating. And some of those began to show there was an intimate relationship between electricity and magnetism. Now, that's not obvious. People were kind of surprised when this took place. And one of the key figures in this was another Christian and another Englishman by the name of Michael Faraday. I put Michael Faraday into a different category. He was more of an experimentalist. He was more of an inventor sort of guy. He didn't have a lot of formal education like the other people were talking about. And he didn't understand a lot of the quote unquote science that we have on this, but he was doing a lot of empirical work. And there are other people involved, but Faraday more than anybody in the first half of the 19th century doing experiments with electricity and magnetism and this intimate relationship between the two. And along this, later on in the 1800s, there was developed this mathematics called vector calculus. Didn't exist before. Necessity is a mother of invention. Calculus was invented by Newton because he needed it to solve some things. Maxwell was using this new mathematical tool. And it's pretty complicated stuff. You get the vector calculus typically in the third semester of calculus, somewhere there. He came up with 4 equations. You have a thing called Faraday's law and a few other laws that describe this. And Maxwell's by these disparate things that people discovered into simple, basic, simple equations. We call them Maxwell's equations. And the more I study Maxwell's equations, the more impressed I am. When I first learned about this decades ago in my education, I didn't quite get it. I understood what was going on, but later on I began to appreciate more and more and more what was really going on here. With time, you learn some of the more important things you missed the first few times through learning these things. But you have moving charges we call a current, and when you have a current like that of moving charges, it produces magnetic fields. And if you change magnetic fields, you in turn produce a current. And there's this interplay back and forth between the two. And the equations that Maxwell developed are these calculus equations, these vector calculus equations to describe that interaction. And he published this up starting around close to 1860 or thereabouts. But he took us 4 equations and he solved them simultaneously. If you've studied algebra or anything else, you can solve more than one equation at a time to solve for several variables. And when he did this, he got a startling result. I don't think Maxwell saw it coming. I don't think anybody else did. But what they found out was the theory is that you have the presence of what are called electric fields and magnetic fields. And magnetic fields, electric fields exist in space. And so if you bring a charged particle in the vicinity of one of these fields, it will move accordingly. Electric field will cause a charge to be accelerated in the direction of the field and a product of the magnitude of the field and the magnitude of the charge. Now, if you have a moving charge, then if there's a magnetic field presence, it too will accelerate. It won't accelerate or will have a force on a static charge, but it will on a moving charge. And there's this complex interplay between the two of those. And so what Maxwell found is that when you solve these 4 equations simultaneously, you get this vibration or a wave at the same time in an electric field and a magnetic field. And you can imagine the electric field is vibrating one way and the magnetic field is vibrating in another way, but perpendicular to the first one. So the electric and magnetic fields are perpendicular to one another, the vibrations are. And this defines a plane. because you have two lines intersecting, that defines a plane. So you've got this plane that the magnetic and electric fields are vibrating in, and this wave is propagating in a direction perpendicular to that plane. So you've got three dimensions there involved. And it's the shocker. The speed of the wave, you can calculate it from his equations, and the speed of the wave turned out to be equal to the speed of light.
Wow.
Is that a coincidence? I don't think so. Maxwell realized immediately, no, this isn't a coincidence. And he said, aha, we have now a very good theory of what light is. And that's been the standard theory for the past century and a half. Light is a wave vibrating simultaneously in electric and magnetic fields that are perpendicular to each other and perpendicular to the direction of propagation. Now, that gave you the prediction of the speed of light in a vacuum, which had been measured at that time, by the way. But it also could predict the speed of light in different media, like glass. You can measure what's called the permittivity of glass and the permeability of glass. And on the basis of Maxwell's theory, you can predict then what the speed of light ought to be in glass or in water or in anything, any substance you would care to talk about. And when you do, you find out that the experiments match the predictions of the theory. You know, this is a tremendous theory coming along here. Again, nobody anticipated this. And furthermore, these waves would not be restricted to just visible light, but it predicted there'd be waves beyond what we could see, beyond in the infrared and beyond towards what we now call radio, and shorter wavelengths as well, the ultraviolet and so forth. And people began experiments and began to find these things. And shortly thereafter, people said, well, wait a minute, we can use this. And they began to harness this, starting in the 1880s, really, with experiments. You've all heard of Marconi, right? The guy who invented the first wireless radio sort of transmission. And it's been off to the races ever since. We use this sort of stuff all the time. All of this goes back to Maxwell. All this goes back to Maxwell. And that's just, when you consider the startling result you get from this, it's amazing. Now, here's the other little kicker that most people don't know, and I learned this, I was stunned. But when you look at Maxwell's equations, it tells you that the speed of light is invariant. What that means, it doesn't depend upon the speed of the source of the light or the motion of the observer. And that flew in the face of everything they knew about wave mechanics. And so at the time, in the 1870s or thereabouts, people kind of shrugged their shoulders and said, okay, well, every theory has its downfall. This is probably it. You know, that's kind of a ridiculous, ludicrous result. So they let it go. Well, Maxwell dies in 1879. About 7 years later, I think it's 1786, these two fellows in the United States, finally some Americans, yay! And they do an experiment in Cleveland called the Michelson-Morley experiment, where they're trying to measure the speed of light in the direction that the Earth is moving in its orbit around the sun. And they used an interferometer to do this, and they were really testing what's called ether theory. The idea developed in the early 1800s, before Maxwell was even born, that light was a wave and needed a wave, some sort of medium to vibrate in. And when Maxwell came along, they didn't quite get that, hey, the medium is simply electromagnetic. They were thinking in terms of a physical medium. So they were trying to measure the speed of light with respect, as we move through space, with respect to this medium they called the ether. And when they did it, they got a no result, which indicated the speed of light was invariant. It didn't depend on what our motion was. And that seemed like a crazy result to them. But if they would have looked at Maxwell's work very carefully, they would have realized that Maxwell had already predicted that. And unfortunately, Maxwell had already died at this point. So and it took them, they wrestled with this for 20 years, 15 years. Finally, a young man named Albert Einstein came up with what's called special relativity, where he's able to explain this by taking the assumption that the speed of light is invariant as a postulate, worked out the details. But I'm convinced that had Maxwell lived another 20 years or 25 years, he probably would have said, aha, you know, my theory already predicted this. I think he would have worked it out. Instead of today talking about theory of special relativity, we'd be talking about Maxwell's theory of special relativity. And today we might be saying, Albert who? You know, we have any idea who Albert Einstein was, because that was his famous contribution. Yeah. So it's just sad that Maxwell didn't get all that. So didn't all the credit for that. I'm convinced he would have done this. Now, Maxwell also made contributions in an area we call thermodynamics. We have this thing called Maxwell's demon we talk about. He dealt with the second law quite a bit. We talk about Maxwellian distribution of speeds. We also talk about Maxwell's distribution in the speeds of particles in a gas. So Maxwell's name comes up in not only electricity and magnetism, but also in thermodynamics and what we call statistical mechanics quite a bit. So again, Maxwell, you can't overrate him. I think he's rated in many respects, and I would put him on par with Newton. If you know, I said before, if Erasmus was the greatest mind of the 16th century, Newton was probably the greatest mind of the 17th century. Maxwell may be the greatest mind of the 19th.
Yeah. And of course, we know that when Newton was around in the 1700s, rather, 1700s, that creation, the view of creation was generally accepted in his day, 6-day creation. But we can see from the dates on the screen with James Clerk, Maxwell, actually, he would have been contemporary with Darwin. He would have came after Lyell and people like James Hutton. So did Maxwell accept evolution? Did he accept an old age for the Earth? What did he believe about those things?
Well, Maxwell obviously, we've got a quote there of the Cavendish lab that he had put up there, Psalm 111:2. Turns out Maxwell was known to be a very devout Christian. Mm-hmm. Spoke of how devout he was. He was a student of Scripture. He really seriously was a born-again Christian, I do believe, from what I've read about him. As far as the age of the universe or age of the world, it's not known what he actually believed. Certainly at that point, you mentioned Lyell and Hutton and now Darwin. Geologists had already been pushing for the Earth to be very old. Biologists were now starting to argue that from others for evolution requiring all of that. And there were a number of scientists who opposed Darwin. People don't know that today. I'm thinking of Sir Richard Owen, the head of the British Museum. He was a contemporary of Maxwell and Darwin as well, and he was strongly opposed Darwinism, and I think Maxwell did as well. However, Owen, he believed in an old Earth. He believed in multiple catastrophes. The flood of Noah was the most recent one, but there are others in the past. This kind of felt kind of melded very nicely with what we call the gap theory, which was developed in the early 1800s. The point is that at the time of Maxwell comes along, the church retreat, needlessly so, but in large retreat before this. So I don't know if Maxwell believed in a universe or world only thousands of years old, or if he believed in one that was much older than that. But it's pretty clear he opposed evolution per se. And just because at that time you opposed evolution does not mean that you opposed vast periods of time. So it's not clear what Maxwell actually believed on the age of the Earth issue.
Yeah, and as you pointed out there on the screen, Psalm 111:2. It's interesting when he was asked to design the Cavendish laboratory at Cambridge, and he had that verse inscribed above the doorway. And originally it was in Latin, and then I think they rebuilt the laboratory back in the 70s or 1970s, 80s. And even though the worldview, I guess, had radically changed again by that time, they still put the verse back up, which was interesting, but not in Latin. They put it back up in English. So they still kept Maxwell's Psalm 111:2 up there on the doors as I guess as a memory to him. But that you could see, when he had that verse put up, it was his Christian belief that it was the framework for his science, and which leads us into the next person, Danny, to Lord Kelvin, or otherwise known as William Thomson. How is he important to science, Danny?
Okay, as you can see there, Lord Kelvin, he lived a ripe old age in the early 20th century, and he's best known for his work with thermodynamics. I mentioned Maxwell is too, but Kelvin even more so. There were a series of experiments done in the early 1800s that led to the formulation of what we call the first and second laws of thermodynamics. There are a couple of more laws of thermodynamics, but those are the two biggies that everybody seems to know. And Kelvin is a key figure in formulating those. The first law is the conservation of energy. Energy can neither be created nor destroyed. The second law says it cannot be created or destroyed. It does get transformed, and as it's transformed, it becomes less and less useful. And while the first law is rather straightforward, it's an equation form and pretty simple. The second law is not an equation form. It's actually done as a form of an inequality, which if you've messed with mathematics much, inequalities can be tricky to work with. And on top of that, it has many, many, many different formulations. If you go through a thermo book, they'll give you Clausius's formulation of the second law. They'll give you Kelvin's formulation of the second law, and they'll give you Carnot's formulation of the second law. They're different formulations, all saying the same thing, but in different ways, expressing it in different ways. And Lord Kelvin was a key person in developing these ideas. And we honor him today by naming the absolute temperature scale in the SI system, the Kelvin temperature scale, because of his contribution. It's a worthy thing to do for him. He also did a little calculation on the maximum age of the Earth and the Sun. With the Earth, what he did is he took the known temperature gradient. At that point, people had dug into the Earth, drilled into the Earth, and they had found that as you go down into the Earth, the temperature increases. I've done a lot of spelunking. It always amazes me when I go into a cave that the temperature is always cooler down there, at least in the summer. It's warmer in the winter, but it's always the same temperature. But I've never gone deep enough. But if you do, you find there's a gradient, something like 25 Celsius per kilometer. So if you go down a mile or so, or a half mile, the temperature really goes up tremendously. And he took thermal properties of the surface of the Earth and was able to show that the Earth is radiating away heat. And so how long could the Earth have been doing that? And he made some conservative estimates, but he assumed that let's suppose the Earth started off as a molten ball. That was the basic theory of the Earth's formation back then, even, and for many years to follow. And he said, okay, let's say it's a molten ball at a very high temperature. It's going to cool off very rapidly at first. So the initial temperature isn't terribly important, as it turns out. And if you let this molten ball cool and solidify and continue cooling, then it's what we call a differential equation in mathematics and in physics. And you can solve those given the current conditions. And he was able to show that the maximum age of the Earth was between 20 and 40 million years. It doesn't mean that the Earth is that old. It simply means that it can be no older than that. And he did a similar thing for the Sun. He argued, he took the Sun, made a similar calculation. He said, okay, suppose it started off, in this case, I'll back up a second. He and a guy named Helmholtz were the first people to come up with a plausible theory for the Sun's source of energy. People had known forever that the Sun gives off all this energy, but once you develop the first law of thermodynamics in the first part of the 19th century, you realize, wait a minute, the Sun can't shine forever. It has to have a source of energy. So what is that source of energy? And Kelvin and Helmholtz worked out and said, look, if the Sun is contracting under its own gravity, it's a very hot gas. As it contracts, it will liberate what we call gravitational potential energy. If you go past a hydroelectric plant, same thing's going on there. And what's happening there is the water is falling from a higher level to a lower level. And we convert that gravitational potential energy, as it does, into kinetic energy of the water moving. And that then pushes a turbine, which then we use to run through an electrical generator to produce electrical energy. It's all first law of thermodynamics and second law involved as well. So he said, let's suppose that the Sun began as a very large ball of gas, much larger than the Sun is today. How long would it take for the Sun to contract down to its current size? And the age for that is around 30 million years, give or take a couple of million years. It's a little less than 40, a little over close to 20 to 30. So he noticed the convergence of these two numbers. That's remarkable convergence. And both of them are maximum ages. Either the Sun or the Earth could be younger than that. Now, what is significant is that in Kelvin's day, late part of the 1800s, the geologists and biologists were arguing that the Earth had to be, and hence the Sun too, had to be at least 100 million years old, about 3 times longer than the two very strenuous computations based on observations and measurements that Kelvin produced. And he pointed that out to the evolutionists, and they had no answer for that. their argument for the age of the Earth, at least a minimum figure being 100 million years, was based upon the assumption of biological and geological evolution. But how much time would be required to explain the geological structures and the different diversity of plants and animals based upon their assumption of what the evolutionary rate of either would be? But Kelvin came along not with speculations based upon a certain model of how things came to be, but based upon actual physical data. Now, all they could argue was at the end of the 1800s, they began to discover radioactivity, and they began to argue that maybe the sun was getting its energy from some sort of nuclear source, but that really wasn't worked out until almost 1940. And it left them for half a century with no mechanism for the sun's internal heat. And in the case of the Earth, they said radioactive decay. And again, that wasn't nailed down until decades later. So people sometimes hear me talk about this, say, well, we've answered that problem. Well, yeah, you have, but you missed the point. The point is, people chose to believe in millions of years, not because of the best data available at the time, but in spite of the best available data at the time. And so Lord Kelvin was very much an opponent of Darwinism. And it's not clear to me if he believed in 6,000, 7,000-year-old creation, six-day creation. He may have, he may not have, we don't know, but he certainly did not believe in 100 million years. He believed in something significantly less than that. Unfortunately, he never really discussed this matter, the age of the Earth, directly, as far as I can tell.
Yeah, and he was sorry, we should have pointed this out at the beginning. He definitely was a Christian, a devout Christian man. If you just look, if you read articles on the web from what Britannica or whatever, they will point out he's a religious man, as if that was strange because he was a great scientist. But he was a very devout Christian, and I do believe that when he died, I think one of who was Darwin's son, who was the astronomer, he was the pole-bearer. Yeah, George Darwin was actually one of the pole-bearers at Lord Kelvin's funeral. But he was a great Christian man. Do you know much about his beliefs and how they impacted his science, Danny?
Not a whole lot directly, just the fact that, all accounts, he was a very devout Christian man, believed in scripture, believed in creation. But beyond that, I don't know a lot of the details about that.
Yeah. So, I mean, we've looked at these three men tonight, and it does show you that, in fact, you can be a great scientist, I mean, as you are, and do these great things without not believing in the Bible. All these three men certainly believed in scripture and went on to do great science.
Can I go back about something of Maxwell I forgot to mention?
Yeah, let's go.
He did something at a science meeting. He was the first to really demonstrate the principle of color photography. What he did is he took a picture. Back then they took photographs on glass plates. These were the way you did photographs back then, film it up and produced yet. And it was all black and white. And he took a photograph of a vase with some flowers in it, with this black and white photography, but he put a red filter in front of the camera. And then he removed that filter, put in a blue filter, and took another photograph, and then removed that filter and put in a green filter and took another photograph. And then he took 3 magic lanterns. These are things back before there were overhead projectors and such. If you were back in the 1800s, early 1900s, if you wanted to illustrate something, you brought in this magic lantern. It was a very bright light source. You'd put this glass plate of a photograph inside, and you could project an image up onto the wall. That was a remarkable invention in its day. There's a story of a famous man here in the Cincinnati area who made early use of that in the 1840s, I believe, to raise funds for an observatory. He's using the best technology of the day. So Maxwell was using current technology. But what he did at the science meeting, he put the three magic lanterns up, all of them with the respective pictures that he had, with a filter in front of it. And as he did that, he combined the red image, the blue image, and the green image, all focused on one. And when they all came together on the screen, people saw a color image. And he showed them, showed 3 black and whites, put the things in right for him, and put them all together. And people were stunned. I understand he got a standing ovation for this. And it wasn't practical yet. It was be decades before, color photography and then with film for movies would be possible. But he demonstrated it decades before anybody else. So that was another brilliant thing that Maxwell did.
Yeah, these were certainly great scientists, but great men of God as well. I just want to, just looking there for a quote, Danny, for the point you made at the beginning about science and a Christian worldview. Let me just say, if I could show this slide. This is from the man I was talking about at the beginning, Rodney Stark. And again, Rodney Stark is not Christian, as far as I know. He's a professor of social sciences in the United States. But in the end of his book, For the Glory of God, How Monotheism Led to Reformation, Science and Witch Hunts, he concludes by saying this: it was not the wisdom of the East that gave rise to science, nor did Zen meditation turn people's hearts against slavery. Science was not the work of Western secularists or even deists. It was entirely the work of devout believers and an active, conscious creator God. And so we can even see how unbelievers would point out the fact that science came out of a Christian worldview. And a slide I always show as well as this slide, and we've talked about some of the men on this screen. Do you want to point out some of the others, Danny, that you may know about?
A little bit about, Linnaeus. He did the classification scheme taxonomy for animals, and he was doing it to try to come up with the biblical kinds. He succeeded in some cases, but really didn't in others. He was trying to identify the species as the kind, and really we're thinking now it's more on the genus or family level for the most part. John Ray, he wrote one of the first books on teleology. I think he wrote it around 1600. When you think of teleology, which is design and purpose in nature, we tend to think of a guy named William Paley, who wrote about 200 years ago, but he was preceded by Ray by a long ways. And he was arguing that, just like Paley did, that design is there of evidence of what we see there. Pasteur, he was a Christian man, I understand. He was the one who studied, put the last nail in the coffin, really, of abiogenesis, the idea that life can arise spontaneously. He had those swan neck flasks that he worked with. It's ironic, as just as Pasteur has put the last nail into the coffin of abiogenesis, it came roaring back with a neo-Darwinism coming, or Darwinism coming along at that point. Pascal, he's interesting. He's came up with what's called Pascal's wager, where he said, look, if you're going to, and he was doing it within some people say, well, his thing doesn't work outside of Christianity. Well, that's fine. In Western Europe, that's all we had was Christianity. But he said, look, if you're going to bet your eternal destiny on there being a God or not being a God, you're going to bet on there being a God every time, because if you're an atheist and you're right, then there's nothing to be gained. You have nothing to lose, but nothing to gain. You die, you're dead, you're done. That's it. But if there is a God and you're an atheist, and by the way, if you're a Christian and you believe in God and you're wrong, there's nothing to be gained or lost either. There's no gain or loss either way. But if there is a God, and if you are an atheist, then there's everything to be lost and nothing to be gained. And if you're a Christian and there's a God, then there's everything to be gained and nothing to be lost in that. So you're a fool to wager that there is no God. That was Pascal's wager, and I think it's piercing logic. But people try to argue, well, outside of Christianity, it might not work. So I don't know about some of the others. Galileo and Copernicus were reasonably devout men, I think. They certainly, at that time, it's difficult to judge. They were both Roman Catholic, and they lived in a world where they had to observe Catholicism. So I don't know a lot about their theology in many respects. Kepler was a very devout Protestant, was the one you got there thinking God's thoughts after him. He explicitly expressed that. And it gets back to this worldview that the Protestant world creates for people, that maybe God is a God of order and impose that order onto the creation. So Kepler was thinking, well, if I study these things and learn some of the principles behind it, then I am sort of more or less thinking the things that God has already thought about in the past. So again, Kepler, by all accounts, was a very devout man, as near as I can tell. I don't know as much about some of the other names that you have there. I did mention Faraday, of course. He was a very devout man. He's more of an experimentalist, an inventor, kind of a tinkerer, but he was a great man of science nevertheless.
Yeah, some great men of God there that founded modern science. But maybe we could end with this thought, Danny. Since modern science came out of a Christian framework, now we've sort of seen the demise of the Christian worldview, at least in the West. What could happen to science once it gets rid of the foundation of if God is the foundation of science, what happens when we get rid of that?
Well, I'm very pessimistic on the future of science. You had that quote there. What was his name? Stark was his name.
Yeah.
And he talks about the specific. I didn't mention this, but it's correct. I agree with that Asian philosophy of mysticism did not give us a rise to science. They believed in yin and yang. Things are totally changing all the time. There's flux, and so why bother looking for patterns? There is none. It's very chaotic, and I see elements of this arising in modern philosophy of science. Back 30 years ago, chaos theory was the big thing. It's still talked about some, but not like it was very trendy then. That there's all this chaos, and somehow arise out of that chaos. There have been many attempts to unite or reintroduce Asian mysticism into science. There's a book written 35 years ago called The Zen or the Tao of Modern Physics, I think it was called. And it was talking about the similarities between the Asian worldview on these things. J. Robert Oppenheimer, the inventor of the atomic bomb, he was fond of quoting the Upanishads. He looked at that as an important inspiration. You have what's called the Copenhagen interpretation of quantum mechanics. I can't recall if we've talked about that before in one of your shows. Maybe we can talk about that sometime in the future. Mm-hmm. But the Copenhagen interpretation gets you back into this kind of yin and yang sort of thing. So I see all these elements converging in modern science, particularly coming out of modern physics, and I think misinterpretations of modern physics, which are taking us back to that Asian worldview that this one historian of science has already argued doesn't get you anywhere. It doesn't produce science. And there was a book written a few years ago called The End of Science. And that thesis of that book, I believe, was we're on the verge of finding the ultimate reality. And basically it's working out the details from that. Well, I think you could write another book on the end of science based on that with a totally different approach that the foundation is completely gone. First of all, we got rid of the Christians. We can't talk about Scripture. We can't talk about God. But now we're going even further in denying that there's this pattern and reality underlying all of this. There's a quote out there. It's been attributed, I believe, to Einstein. I don't know if it's a real one or not, but it certainly sums up what many modern physicists seems to think. And it's this: the most incomprehensible thing about the universe is that it's comprehensible. And I think people like Newton, if they heard that, would slap them upside the head, say, "What's the matter with you?" That's the whole point. If the world is comprehensible because God is comprehensible, God is knowable. And so I'm very pessimistic because I think the philosophical basis of that made science possible 400 years ago has been totally destroyed. It's been replaced by the sort of worldview that does not lead to science in the first place. So I don't know what science will be like in another 100 years, but I think we may be heading for some stagnation in it.
Yeah. There's your next book, by the way, Danny, on the end of science.
End of science, really, yeah.
Yeah. Well, it's an encouragement if there are young people watching tonight, get involved in science and apply your Christian worldview to the fields of science, because we certainly need that. We need to recapture science for the glory of God. That might sound very difficult given the world that we live in today, but nothing is impossible with the Lord, and we certainly do want to recapture science for the glory of God. So, I don't see any questions coming in, Danny, but there's been a lot of people watching, and it's been thoroughly enjoyable. Great to learn about these men of God and how they have made great impacts in the field of science. So thank you for joining us, and thank you everybody for taking the time to watch tonight.
Thank you.
Thanks, Danny. Yeah, good night everyone, and thank you for watching.